Knowledge Nexus.
Hey there, fellow explorers of the digital realm. Welcome to a journey where we uncover the hidden forces that make our digital lives possible. Have you ever stopped to think about what makes your computer tick? What is it that allows you to browse the web, play games, or even just type a document? It's not magic, though it can seem like it sometimes. The real magic lies in the intricate dance of software and hardware. The answer lies in a powerful piece of software called an operating system, or OS for short. This software is the backbone of your device. Operating systems are the unsung heroes of our digital lives, working tirelessly behind the scenes to make our computers, smartphones, and other devices function seamlessly. They are the silent conductors of our digital orchestra. Imagine a bustling city with traffic flowing, buildings standing tall, and people going about their day. Just like a city needs infrastructure to function, our devices need an operating system. An operating system is like the city's infrastructure, ensuring everything runs smoothly and efficiently. It manages the traffic of data, the flow of information, and the execution of tasks. Without it, our devices would be like cities in chaos, unable to function effectively. Imagine trying to navigate a city with no roads or traffic lights. Utter pandemonium. From the moment you turn on your device to the time you shut it down, the operating system is hard at work, managing resources, executing commands, and providing a platform for all your applications to run. It's the unsung hero that keeps everything in check. In this digital age where we rely on technology for everything from communication to entertainment to work, understanding operating systems is more important than ever. They are the foundation upon which our digital lives are built. So, buckle up as we embark on an exciting journey to unravel the mysteries of these essential pieces of software and discover how they shape our digital experiences. We'll dive deep into their functionalities, their history, and their future. Get ready to be amazed by the power and complexity of the often invisible world of operating systems. They are the silent guardians, the watchful protectors, and the unseen architects of our digital universe. Let's face it, the term operating system might sound a bit intimidating at first. But fear not, my friends, because understanding the basics is easier than you think. In simple terms, an operating system is a software program that acts as the intermediary between you, the user, and the hardware of your computer. Think of it as the conductor of an orchestra, coordinating all the different parts to create a harmonious symphony of computing power. Just like an orchestra needs its instruments, an operating system needs hardware to function. This includes the central processing unit, memory, storage devices, input-output devices, and more. The operating system manages all these hardware components, allocating resources and ensuring they work together seamlessly. But that's not all. The operating system also provides a user interface, which is the visual environment you interact with, whether it's the familiar desktop of a Windows PC or the sleek icons on your smartphone. This interface allows you to easily interact with your device, launch applications, manage files, and perform various tasks. In essence, the operating system acts as the bridge between you and the complex world of computer hardware, making technology accessible and user-friendly. Now that we have a basic understanding of what an operating system does, let's dive a little deeper and explore some of its core components. These components are the building blocks that make the operating system function smoothly and efficiently. Don't worry, we won't get too technical. We'll break it down into simple, easy-to-understand terms. Think of these components as the different departments within a well-oiled machine, each with its specific role to play. Just like in a company where each department has its own responsibilities, the components of an operating system work together to ensure everything runs smoothly. First up, we have the Hardware Abstraction Layer, often abbreviated as HAL. This crucial component acts as a translator between the operating system and the underlying hardware. It ensures that the OS can communicate effectively with the hardware, regardless of the specific details of the hardware components. It provides a consistent interface for the OS to interact with different hardware components, even if they come from different manufacturers. This means that the operating system doesn't need to be customized for each piece of hardware, making it more versatile and adaptable. This abstraction layer allows software developers to create applications that can run on a variety of devices without having to worry about the specifics of each hardware configuration. It simplifies the development process and ensures that applications are more compatible across different systems. Next, we have the kernel, which is the heart and soul of the operating system. The kernel is the core component that manages the system's resources and ensures that everything runs efficiently. The kernel is responsible for managing the system's resources, including memory, processor time, and input-output operations. It allocates resources to different programs and processes, ensuring that each one gets what it needs to function properly. It acts as the central hub, controlling access to the hardware and ensuring that all running programs have the resources they need to function correctly. Without the kernel, the operating system wouldn't be able to manage the hardware effectively. Of course, no operating system would be complete without device drivers. These small but essential programs play a crucial role in the functioning of the OS. These small programs act as intermediaries between the operating system and specific hardware devices, such as printers, scanners, and network adapters. They ensure that the OS can communicate with and control these devices effectively. Each device has its own driver, which tells the operating system how to communicate with and control that particular piece of hardware. Without the correct drivers, the OS wouldn't be able to use the hardware properly. Last but not least, we have the user interface, which we touched upon earlier. The user interface is the part of the operating system that you interact with directly. This is the part of the operating system that you interact with directly, providing a visual representation of the computer's resources and allowing you to control its functions. It includes elements like the desktop, icons, and taskbar, which make it easier for you to navigate and use the computer. The user interface can take many forms, from the traditional desktop environment to the touch-based interfaces of smartphones and tablets. Each type of interface is designed to provide an intuitive and user-friendly experience, making it easy for you to interact with your device. Just like there's no one-size-fits-all solution for everything in life, there's no single operating system that rules them all. In fact, there's a diverse world of operating systems out there, each designed for specific purposes and devices. Let's take a look at some of the most common types. First, we have desktop operating systems, which are the most familiar to most of us. These operating systems, such as Microsoft Windows, macOS, and Linux, are designed for use on personal computers and laptops. They typically offer a wide range of features and applications, making them suitable for a variety of tasks, from browsing the web and editing documents to playing games and creating multimedia content. These systems are robust and versatile, catering to both casual users and professionals alike. Next, we have mobile operating systems, which power our smartphones and tablets. These operating systems, such as Android and iOS, are optimized for touch-based interaction and mobile connectivity. They typically prioritize battery life and performance on smaller screens, offering a streamlined experience for tasks like communication, web browsing, and running mobile apps. These systems are designed to be intuitive and user-friendly, making it easy for anyone to pick up and use a mobile device. For businesses and organizations that need to manage large amounts of data and support multiple users simultaneously, there are server operating systems. These powerful operating systems, such as Windows Server and Linux distributions like CentOS and Ubuntu Server, are designed for reliability, security, and scalability. They provide the backbone for websites, databases, email servers, and other critical infrastructure. These systems are built to handle high traffic and large volumes of data, ensuring that businesses can operate smoothly and efficiently. Finally, we have embedded operating systems, which are designed for use in smaller, specialized devices. These operating systems, such as FreeRTOS and Contiki, are often found in devices like smartwatches, fitness trackers, cars, and industrial equipment. They are typically designed to be lightweight and efficient, with a focus on real-time operation and minimal resource consumption. These systems are crucial for the functionality of many modern devices, ensuring they run smoothly and efficiently without consuming too much power or resources.